have summer and spring, and summer and spring. Like 1 week of winter. All right, so a few people here who have worked in 224. So my name is Nick Macias. I'm teaching this for not the first time, probably not the last. And I'm not going to spend the first day going over administrative details because that's not fun. So, does everybody have Canvas access? Okay. So you can find the syllabus for the course. That's not the most interesting thing, though. The additional information is more pertinent. That's the stuff that's specific to this offering of the course. You can also find the syllabus on engrcs.com. And one of the many diversions I had over break was rewriting the engrcs.com website. So we have a new fangled website.
Does it look like old days? Yeah, I know. Does it look like old, like?
I know. So, but it's linux.engrcs.com. But it's got, among other things, all the syllabi laid out.
Nice.
So you can get to it through that.
There we go.
All
You
right.
didn't use Flash though, right?
Hmm?
You didn't use Flash though, right?
No Flash.
Okay.
Yeah.
Just making sure.
It's all Bootstrap. It's all responsive. Collapsible menus. Good stuff. All right. So let's just cut to the details.
We got a space station as usual.
It is a space station. So, so syllabus, the textbook is open source. You can download it from there. I recommend downloading it once and saving it. It's a reference to data structures. It's not a book that we're going to follow in this course very closely, but we're talking about things that are very standardized: linked lists, binary trees, AVL trees, red-black trees, hashes, things like that. And all of these different types of data structures are discussed in this text. You can use any text you like. You can go online, you can find all sorts of resources. If you're having trouble figuring out how to balance an AVL tree, feel free to Google it, okay? But here's what I don't want you to do. I don't want you to Google code. There's a distinction here. There's algorithms and data structures, and how do we do these things? What's the algorithm for traversing a binary tree in this order? That you're free to talk to each other about. Go online, read the wiki page, put yourself on Stack Overflow, whatever you want, okay? But then there's, what should my C code look like to actually do these things? That I don't want you to get from other people. That I don't want you to look up. That you have to write yourself. The emphasis of this course is the data structures and the algorithms. And to some degree, we'll talk about the C language aspects that will help you do that. Pointers, arrays, addresses of variables, memory allocation, things like that. But the coding itself has to be yours, has to come from you. Okay, is it clear what the difference is there? All right. So nothing magic about that textbook, but it's online. You can read the assessments, the course outcomes, and the boilerplate course policies on plagiarism and late assignments and all that kind of stuff. Tentative schedule may or may not follow this, probably not going to follow it very closely. But the set of topics in here is close to the set of topics we'll cover, but we're going to do things in our own special way this term. All right, course policies, additional information. So there's two sections of this course, one from 11 to 11:50, 5 days a week, one from 12 o'clock to 2:05, 2 days a week. You're free to come to either section. The early section is very full. There's 32 or 33 people in there this morning, and not everybody showed up. That's why you got extra tables. This section's probably going to be fairly open. So it'll be a little more of a relaxed pace, a lot more interactive. If you can keep coming to this one, that's great. But you're free to come to either or both. My office is room 115. It's on the opposite side of the collaboratorium. Just walk through. I'm right next to Izad. I will be there Monday through Friday, 9 to 10. Those are my official office hours. If you want to meet some other time, just let me know. And there's a lot of afternoons I can stick around, but usually not Mondays. Mondays are the worst day. And on that topic, Monday's class will not go till 2:05 because I have another class starting at 2. So the 2:05 thing makes the number of minutes work out correctly. But we probably won't go all the way till 2:05. And on Wednesdays, if people want to stick around that long, right, we can. But we'll probably tend to lose steam closer to like 150, 155. All right, if you want to reach me electronically, this is your only good option, nmacias@clark.edu. Don't send me email through Canvas if you want me to see it, because I'll get a notification, I can go to Canvas and log in and find the email and read it, and then I can reply. But it's a very kind of indirect process. The worst option, though, is when you turn in a programming assignment, I'll give you a grade. Sometimes I put comments in that little comment block. You lost 5 points for this, but the rest of the code looked great, nice job. Don't send me messages in that dialogue. Okay, those I will never see, unless you tell me I put a comment in the comment section for PA2, can you go read it? Okay, so send me an email, nmacias@clark.edu, if you want to reach me. Your grade, all right, service learning project 10%, same as last time. Final exam 25%, midterm 20%. Programming assignments, this first item 20%, you're going to have 5 programming assignments. Much like in 224, they're going to be roughly 2 weeks each. And they'll be fairly comprehensive assignments. You'll be putting lots of concepts together and documenting your code and making sure that it does everything it's supposed to do and submitting it through Canvas. There's a new component to the course, which I call one-day programs. These are just what they sound like. They're 24-hour programming assignments. They'll probably take you 10 or 20 minutes in some cases. Okay, we'll come back and say more about those in a minute. The other new component is quizzes. We're going to have in-class quizzes online through Canvas. This is a bit of an experiment, okay? That's going to be 10% of your grade, though, is these online quizzes. 2 reasons for this, well, a few reasons for this. One, it's an attendance reward, right? You come to class, you get to take your quiz. And the quizzes will be locked, and to unlock them, you'll need a code, which I'll put on the board at the beginning of the quiz. So if you're sitting at home and you decide to take the quiz from there, it's not going to work. So it's an attendance reward. 2, it's going to help you sort of keep up with stuff as we're going through the material, same as the one-day programs. And 3, since they're online, they'll get graded immediately. And if they get graded and you don't like your grade, you can retake it if you do it within the time limit. So but these will be pretty simple, just sort of refresher of things typically that we've done the day before. So we'll do one of these quizzes today, and everybody can get 100% on it, I guarantee. Everybody in the last section got 100%. But it brings us to the topic of online access. So ideally, if you come here with a laptop and you can get onto Clark's Wi-Fi, you're good to go. Okay, you can get on Canvas, you can take the quiz and so on. If you don't have a laptop and you have a tablet or a smartphone and you feel like you can confidently work with those, that's a good option. Okay. If you do not have a tablet, a smartphone, or a laptop and you're not in a position to have one for this course, let me know. And we have these little purple tablets with keyboards. We've got 10 of them back there on a charger, and I can make those available to you. All right. Keys to success, I'll let you read those. Basically, come to every class, come as much on time as possible, stay the whole time, try to stay tuned in. Okay, 2 hours is a long time. I will try very hard to take a break at 1 o'clock. If I forget, you can throw something at me and say, can we take a break? The other key is do the work outside of class. Okay, the stuff that we go over, leave class, go work on it. Okay, you've got to be writing code. You've got to be trying these things out in order for the concepts to actually sink in a way that's usable. I had a student, former student, come by last week and visited me. I was doing some stuff in my office, and he's at PSU right now, and he told me he's having a really easy time because the coursework over there seems really watered down. And he says everything that they're doing we already did in the 200 sequence here, but he said it was a little unnerving when he went for his admissions because they gave him an admissions test, and they basically stuck him in a room in front of a computer, no notes, no books, no network access. And they gave him an editor, and they asked him to write a piece of code. And I don't know what it was doing, it was some kind of data structure, a linked list or something like that. And he had to write it from memory, from his head, from his understanding of what a linked list is. He had to construct this code and get it to run. And he said there was someone like pacing around watching him while he was doing this, which was really unnerving to him. But he was able to do it, okay? That's the level that you would like to be at when you leave this course, when you leave Clark. Okay, not that you memorize the code, but that you understand the concept. I know what a linked list is, and I've written code before to implement a linked list, so now I think I can write code again to implement a linked list. And those weird little 2 details that took me 5 days the first time, I know how to do those now, right? Because I learned something about memory allocation. So that's what we're shooting for. All right, along the lines of keeping up with the subject as we're going forward comes the one-day programming assignments. So here's the idea. A few times a week, sometimes more, this week there's going to be 4 of these things, I will announce a one-day program that you need to write. For now, it's usually going to be just a short function, a C function that does something. And this will get posted on Canvas usually 8 o'clock in the morning, and you have until 8 o'clock the following morning to complete this program. So it's a one-day thing. And the intent is to, 1, give you some practice at writing code, 2, to give you some more points to bump your grade up. But the main point is to have you writing code as we're going through subjects in lecture, as you're working on your larger programming assignments. These one-day programs will be pieces of that process. Okay? The other thing about the one-day programs is they're automatically graded. You're not going to submit them to me. I'm not going to look at your code. So if you want to write code with no comments or evil comments about me or something, you're free to do that. You're going to write this code and you're going to run it into an automated testing system. And it will analyze your code and it'll give you a grade. And if you don't like the grade, you can make some changes to your code and you can resubmit it. It'll grade it again. And you can do this as many times as you want within 24 hours. All right. So how does this work? So there's a video that I made. It's my usual stellar video quality, which means it sucks, kind of. There's a link to it on Canvas. It's a 7-minute video. It's on YouTube. It basically says and goes through what we're going to do right here in the next, I guess, 7 minutes, which is introduce the testing system, and we'll go through an example and show you how it actually works. Okay? And your first one-day program is already posted, and it's due tomorrow morning at 8 o'clock, meaning you have to submit it for grading before 8 o'clock tomorrow. After 8 o'clock tomorrow, the testing system shuts down, and you can no longer submit it for grading. All right, so let's look at the assignment itself first, and then we'll see how to use the assessment system. So this is test 001, and it's a function. Your job is to create a C function named sum that takes 2 integers and returns their sum. So you're going to write something like integer sum. That's a prototype for it, right? Your actual code might be something like this. All right. That's a perfectly fine version of your program. Now, to submit this for grading, what we're doing is using the idea of a test bed. So what's a test bed? It's a platform into which you take the thing that you're trying to test, you put it in that platform, and then a series of tests are run on it, and the outputs are analyzed, and it assesses how well this thing works. It's a general engineering concept. In our case, our test bed is a program called main.o that's sitting under the directory /temp. And main.o is basically a precompiled main program. So here's what you want to do. Write yourself a function. You can call it whatever you want. It can go in a file with any name, but the function itself has to be called sum. And it has to expect 2 integers and return an integer. Okay, after you've got this function, write yourself a main program and test it. Make sure this thing works. Okay, so write a program and call, something like this. So here's my main. Integer x equals sum 2, 3, printf x equals %d \n, x. There's my main program. And when I run this, it should print out x equals 5. If it doesn't, if it's seg faults, if it bursts into flames or something, I've got a problem, go in, edit your code, do your debugging, run GDB, whatever, okay? Once you think you have this function working correctly, you're ready to try it with the automated system. So you want to build an executable, and in this case, this is the command you're going to use. And this may change from assignment to assignment, but it's going to be something like this. This is saying, run GCC, compile my sum.c. That's just a function, it's not a main program. There's no main in there, there's no include stdio.h. It's just a function called sum. So compile that and put it together with this test bed, main.o, which does have a main program in it. I said call the output main, you can call it whatever you want, you can use a.out if you want. Well, after you type this command, you should be left with an executable program that uses your sum function in this pre-existing test code. All right, now in this case, I'm telling you what the main program does. I won't usually do this, but if you just want to play with it a little more, if you say main, you type in 2 integers, it should produce a line of output like this. First number plus second number equals sum. Okay, pretty straightforward. Once you think your code is correct and you're ready to assess it with the automatic system, just say assess and the name of your executable, main in this case. And that'll start the assessment system, and there's a series of options that you have in there. You can run a series of tests, you can ask for more detail on each test, and when you think it's passing all the tests, you can say go ahead and grade it. It'll run another series of tests, tell you the score on each test, and record that grade in the system. If you didn't get a perfect score, you can go back, make some changes, reassess, regrade, and I'll always keep the latest grade. Okay, so you can do this as many times as you like. And then sometime a few days later, those grades will show up in Canvas miraculously. A process that doesn't exist yet, but it will soon. All right, good so far? All right. So I'm going to go in as a username test. And let me peek at my code first. Okay. So I've got I come in here and I'm working on my sum program. So there's sum.c. And here's what my program does right now. I threw some comments in because I'm so in the habit of making comments that I had this, even though no one's going to see it. There's my integer sum, takes 2 integers a and b. And I couldn't figure out how to add 2 integers together, so I went to Stack Overflow and I found some code, and so I put this in here. So there's my attempt at a sum function. All right, so what do we want to do? We want to use this compile command to build the test bed. So gcc-o main, well, let me do this first. So you have some problem with your code. So gcc-o main/temp/main.o, and then the program that you want to actually compile. And I get compile errors, okay? That's the first set of issues you need to deal with. You need your program to compile successfully. And hopefully you've already written a main program and tested this and you caught those. And so you go in and you make those changes. Oh yeah, this should have been a comment. Okay, fine. Recompile, hey, it compiles perfectly. So now I have an executable program, main. Generally, you won't know what this is supposed to do. Okay, it's a test bed. It's something that was given to you by the customer that you're writing this code for, right? But in this case, I told you what main does. Main takes 2 arguments and it prints out 1 line of output that shows you what the sum of those arguments are. And it happens if you don't put in any arguments, it's seg false. And it does all kinds of things. And in general, you're not going to care what this version of main does. You're going to write your own program to test this. Once you know it's ready, you're simply doing this GCC to create this accessible version of main. All right, so we're ready to assess. So just say assess main. And we get a set of options. So the idea of the system is there's a series of test files available. And I can ask the system to run my code on any of those test files. And it will run your code, and it will compare it to what happens when it runs my code with the same test file. And the output should be the same. If they're not, one of us did something wrong. Guessing it wasn't me, but it's possible. All right, so you can run a series of tests, and it will compare the output to the expected output, and it will give you a score from 0 out of 10 up through 10 out of 10. So what can we do? We can type a question mark and we can see what tests are available. In this case, we've got 3 tests available to us, test 1, 2, and 3. So if I want to run one of these tests, the command is just t space and the name of the test. So I can say t test 1, and it says results 10 out of 10, no differences detected. That's what you want. Okay, that means your output agreed perfectly with the expected output. So you get 10 out of 10 for that. Cool. Let's try test 2. 10 out of 10, no differences detected. Excellent. One more test. Let's try test 3. Uh-oh, something went wrong. So I only got 6 out of 10 on this test. And it will show you a series of output lines. A less than sign means something that your program printed out. A greater than sign is something that my program printed out. So the only difference in the output was that somewhere you said 0 plus 0 equals minus 1. You should have said 0 plus 0 equals 0. Well, it's 7:50 in the morning and this is due in 10 minutes. I don't care about 6 out of 10. I'm just going to go ahead and turn this in for grading. So an uppercase G says submit your code for grading, and it just goes ahead and runs another series of tests. So right now I've got 46 out of 50. That's not bad. And if I just log off and don't worry about this, I got a 92. Okay, but you want to actually figure out what went wrong, right? So remember when we ran test 3, we had some differences. So in uppercase T says run a test, but give me more information about it. So if I say uppercase T test 3, it also shows me the arguments that were used when it called your program. In this case, it called it with 2 arguments, 0, 0. And if it sent anything to standard in, it will show you what it sent up here. In this case, it didn't send anything to standard in. But it executed it with the command main 0, 0. All right, so I can quit this, and I can try this manually, main 0, 0, and yeah, sure enough, there's something going wrong there. All right, I haven't shown you what the program main.c looks like, and I'm not planning to. But this tells you that there's probably something going wrong when your sum routine is trying to add 2 zeros. So this is where you get to practice debugging, right? You wrote a main program and you tried your code and it looked like it worked, but I found a test case where it doesn't. You've got to figure out what that test case is also. So go back, write a main program, run some more cases, play around with zeros for your inputs, and start looking at your code. And oh yeah, here's the problem down here. This was a silly thing to type. I should have just returned A plus B instead of that crazy thing I found online. So now I think this is my good sum.c. I'll recompile, I'll reassess, I'll try test 3 again. Hey, test 3 looks like it works. I want to make sure I didn't break those first 2 tests. Well, there's another command A which just says run all of the test files. So I can type big A and I see 10 out of 10 on all 3 tests. That looks really good now. I'm ready to submit for grading, put in a big G, 10 out of 10 5 times, I'm done. All right.
Submit for G, when you submit G, that's the final one, or?
That's the final one.
Okay.
Yeah.
So no resubmits after that? Or?
Yeah, you can resubmit. You can submit as many times as you like. But the system will always take the last one. So if you submit it and it works fine, and then you break it and you resubmit it and you only get 20 out of 50, you're not going to get that 50 out of 50 unless you fix it. Okay, I'm never going to see those earlier submissions. And don't come to me and say, can you go back and grade the previous one that I submitted, because it's going to be a real pain to try and do that. All right, make sense? Oh, the video was faster. So I get a file that shows me, and I'm just looking at the end of it here, shows me the assignment number, the user ID, the time and date, and the score that they got. In this case, there was 46 out of 50 and then 50 out of 50. So the grading code will pick up the 50 out of 50 at 8 o'clock tomorrow, and the student would get 100 points out of 100 on that assignment. Does that make sense? All right, this is an experimental system, okay? Like I said, this is something I went a little crazy over Christmas and threw together. I think it's fairly safe, but who knows?
It's possible it can be overloaded, I think.
You can do a denial of service through this, right? Don't do that. But you could, run the assessment system 10,000 times and probably use up all the resources. But everything is logged as you do this, so I can see exactly who does what, when, and so don't do that. If you try to run a test that doesn't exist, it'll just basically seg fault and kick you out. If you have problems in your code, you may get exceptions like this. Okay? No guarantees what it's going to do if your code doesn't work. But if your code does work, it should proceed as we've just seen. All right, so ODP1 is already posted on Canvas, and you can do that anytime before tomorrow at 8. I suggest doing it sooner rather than later. I'll be on campus until probably 4 today. So if you try it after class and it's not working, you can come by my office or shoot me an email and find me. I'll be in 126 probably, and we can figure out what the problem is. One thing that caught somebody in the last section is if you're running the assessment system and your internet connection dies, and you come back in and you try to assess again, you may get an error message because it's currently running in one instance already and it won't let you run multiple instances. So a few things to keep in mind. Remember the PS command for seeing processes? If I say PS dash full username and then your UID, Nick in my case, it shows me all the processes that are currently running associated with me. If you have a process named assess already running, you want to kill it. You can say kill space and then put in the PID of that process. A quicker way may be pgrep-lf assess. That'll show you any processes you have running under the name assess, and pkill-f assess is quick but possibly dangerous. This will kill any process you own that has the word assess anywhere in the name. But just be aware of that. All right, so the code should work. If it runs into any weird issues, definitely let me know. Or if you have any feedback on it, let me know. Let's see how it goes. Any other questions, comments, concerns? Let's talk about data structures. Oh, no, not yet. Talk about your second. I'm going to mess this up at some point, probably multiple times, because we're only meeting Monday, Wednesday, right? So ODP 2 is going to be posted tomorrow morning at 8, and will be due Wednesday morning at 8. So let me talk about it today, since we don't meet tomorrow. So one day program 2 is very similar to your sum program, but instead of taking 2 integers, it takes an array of integers and an argument that says how many numbers are in that array. So a prototype would be something like integer sum int star comma int. So a main program might be something like integer x bracket 5, x0 equals 2, x1 equals 4, x2 equals 7. I don't care what these are. So I'm setting values into integers, and I want to say something like answer equals sum of x comma 5. And my sum function should take this array, and it should look at this integer, should add up this many numbers in this array, and return the sum. So I would expect that after this, answer would be equal to the sum of these 5 numbers. Okay, so again, you're just writing a function named sum. But instead of taking 2 integers, it takes an integer array and a number of elements, and returns the sum of those. The test bed will still be main.o, but it's not the main.o that's there today. Right, it'll be after 8 o'clock tomorrow. So build your executable and assess it using assess. You're going to want to test this manually, right? So write yourself a main program to do something like this, or be more clever.
Did you automate the switchover?
Say what?
Did you automate the switchover?
No.
Oh, you just listened to.
I gotta do stuff. But I was going so crazy with this, and I was like, you know, this might not even work after the first week. So I put the brakes on, and I said, let's see how this works, and then we'll embellish accordingly. All right, so write some test code, make sure your function works, build a test bed with the GCC command, and then assess it using assess. That'll open tomorrow morning at 8. The assignment will be available on Canvas automatically tomorrow at 8, and you'll have 24 hours for that.
So will not always be a class day that it's on.
Correct,
Okay.
yeah.
Cool.
All right. Now let's talk about data structures.
Can I ask a random question?
Sure.
Of all the things they could have done to modify the classroom, you know, like parallels and stuff, what are these little blue and red floaty drone things above our head? I don't think I remember those.
Oh, those?
They were there before.
It's probably a monoxide detector, I would guess.
It blinks a lot for that.
Just because it kind of looks like that.
I don't know, maybe I
Maybe
was
You're
always,
sitting in the front row, so you
I was always sitting in the front row, so I was right ahead of it.
It could be talking to the fillings in my teeth, though, I don't know.
Well, we got this, which looks like an infrared sensor, and that, and it's like,
That's so they can watch you.
it's a lot of blinking for a.
But I know that thing is a CO2 monitor. So they got curious, and I breathed heavy on it for a minute, and the number skyrocketed. So I started like trying to get it to go down again. All right, data structures. So data structures are one of those 3 keys to being a really, really good programmer, right? The kind of programmer people fight over and try to give you more money than anybody else in order to hire you. Okay, so my claim, just from what I've observed, 3 keys to being a highly successful programmer. The first is a good command of data structures. Second is effectiveness at debugging. The third is the ability to do rapid prototyping. Be able to take a problem and come up with a quick and dirty version of it that works right away, and then build on that. Okay, and we'll have some practice with all of these things in this course. Data structures being the most prominent. So what is a data structure? Basically, it's the idea that when we write programs, we're trying to process information, okay, data. And to the computer, the data is just a pile of bits. It's just a bunch of ones and zeros. Now, there's a bit of organization. They're organized into groups of 8 or 16 or 32 or 64 chunks to make what's called a word. But really, it's just a bunch of ones and zeros. It's a bunch of capacitors that are charged or discharged to store a 1 or a 0. And that's it. But as programmers, we see data in more sophisticated terms. For example, we see that pattern of bits and we might think the number 5. To the computer, it's just 8 bits. But we might say, okay, but these 8 bits are part of an 8-bit integer stored using 2's complement weighted positional notation, and so this represents the number 5. Or this, which is the number 65, might mean the character uppercase A. So we already have some notion of treating data as more than just a big pile of ones and zeros. Now suppose you were asked to write a program that could take a series of integers and calculate their average and return that as a function value. And don't worry about rounding, just do sum and divide with integers. And you've never heard of an array. Don't know about arrays. You don't know about var-args. If you know what var-args are, forget about those. So how would you write, these markers are dying quickly. How would you write a program to compute the average of, say, up to 5 numbers? You what?
Use the assembly count.
Yeah, but how do you pass your numbers to this function?
Do you want to do it 1 entry at a time until you stop giving it entries, or do you want to do it all in one line?
I just want to pass it up to 5 numbers. I may only want to take the average of 2 numbers. But in the absence of an array, I got to do something like this. Right?
What's the last one?
Length. So that tells me how many numbers I actually care about. And my code is going to look even worse. Well, if I only care about one number, I'm going to assume it's the first number, I'm just going to return that as the average. But if I was given 2 numbers, I'm going to add the first 2 numbers, divide by 2, and return that. And so on. Horrible code. It works.
I forget, can you declare, oh gosh, what's the exact word, when you initialize a value, can you initialize them all to 0 when you declare them up there, and then just whatever gets passed through gets passed through?
So you can just add them all together?
Yeah, and then like make the length the first one, and then just say n1 equals 0, n2 equals 0, and then you just go,
I mean, yeah, maybe, and we wouldn't do this, but technically, when you call average, you've got to pass it 5 integers plus a 6th integer.
I'm just thinking of short wisdom. I'm
Yeah.
thinking of something for C#.
So this is goofy, right? This is not something we want to do, but if you don't have an array and you don't have something fancy like variable arguments or something like that, this is what you got to do, okay? But this is where the problem is coming from. Because the numbers that we're passing to this are not just 5 integer variables. They have something to do with each other. They're all part of a set of numbers that we want to average. And it would be nice if we could somehow treat this collection of numbers as a single entity and get to the individual pieces of that entity in order to access those individual numbers. That's what an array is. Okay, an array is a really rudimentary type of a data structure. So when I say integer nums bracket 1000, I can use the word nums, N-U-M-S, as an argument to a function, for example, and it means 1,000 integers. And why does this work? It works because when I make this integer declaration, somewhere in the memory of the computer, it will find a location where it's going to store nums bracket 0, the first number in that collection. And at the next set of memory locations right after that, it's going to store the next number. And at the next location after that, it will store the next, and so on. And when I say nums, N-U-M-S, that means the address of this first element, nums bracket 0. Now, if a subroutine knows the address of the first element, it can find the address of this element by just adding 4 or 8 to this address. And it can find the address of this by adding another 4 or 8. If it's a 64-bit machine, it'll be 8. And it can find the address of entry 500 by adding this 8-byte displacement 500 times. So take the address of this number, add 500 times 8, and you got the address of element 500. So this is an example of a data structure. Okay, it lets us take these pieces of information and say these go together somehow. And so we're just going to call it by this name, and you can get to all the individual pieces through that name. But that's still slightly suboptimal. So our average routine now looks like this. And are you comfortable with this integer star idea for an array? Right, because when we say nums, under the definitions of C, this means the address of the first element. Okay, nums is the same thing as address, nums bracket 0. And down here, when we pass nums, we're simply saying that's the address of an integer. And C lets us then say things like nums bracket 0, nums bracket 500, or more generally, nums bracket a variable. And we can get to those pieces. So if you're not up on passing arrays, practice, right? And that's one-day program too. So that's a chance to work with that. But this is slightly cheeseball still because we're trying to average this array of integers, or we want to print out the elements in that array, or we want to calculate the standard deviation of the elements in that array. So we might have void print integer star nums and integer length. Or we might have an integer standard. Do you know what standard deviation is? It's just a measure of variation of a set of numbers. It's like the average square divided by a square root of something. It's fun. So I can do standard deviation of those nums and the length, and so on. But every time that I talk about this array of integers, I also talk about its length. And I've got to treat those two together. If I just pass this array to something, there's no way for that subroutine to know how many things are actually in this array. I can tell it it's an array of 1,000 integers, but does it actually have 1,000 values that I care about? So think about character arrays, strings. Why do we put that null terminator at the end of a string? Because if you have an array of 120 characters, you may not actually be using 120 characters in there. Your string may contain HELLO, and that's it. So we could pass around the number 5 along with that array of characters, but we have a convention, which is we're never going to really care about character 0, so we'll put a character 0 at the end. We don't have that option with integers. We could say, well, I don't care about negative numbers, so I'll store my integers in this array and I'll put a -1 at the end. But in general, we can't do that, because all integers are fair game. So we constantly have this array and this length. And it's no difference in some sense from that first case where we had 5 integers that we were passing. These things really belong together. So what do? We use a structure. So we could use struct myData, and we say it's got an integer array piece called nums, and it's got a length piece. So struct is a keyword. It's followed by the name of the structure, curly brackets, and then the types of variables that we want to include in that structure. And once I've declared this, I can do the following: struct myData, and then the name of a new variable, x. And now x is a collection of 2 pieces of information: an integer called length and an integer array called nums. And that array nums is itself a collection of a bunch of pieces of information, the integers and the array. But I've gathered them together, and I can just use this symbol x to represent this pairing of information. So now, these routines could simply take a struct myData, whatever you want to call it. And by just passing this one thing x to a function, that function has access to both of these pieces. Okay, that's a more data structure-y idea of a data structure, because these things belong together. All right, so how do we use this? We've got struct myData. It's got 2 pieces to it. We said struct myData x. So I can say x dot nums bracket 0 equals 5. So x dot nums means this piece of the structure. Okay, so I'll call these fields. So there's a field named nums and a field named length. X dot nums refers to the field called nums. It's an array, so I can access elements using brackets. So I could set up values like this. X nums bracket 1 equals 17. X nums bracket 2 equals 12. And if I only want to store 3 pieces of information in this structure, 3 numbers, I would set the length, x dot len, equal to 3. And now, as long as a function that's using this understands how this structure is set up, I can just pass around this single symbol x. So my average routine So integer star, I'll just call my array in, and I'll make my length an integer called how many. And I'll do something like sum equals 0. Or whatever. Right, so here's a simple for loop. It just goes through and it adds each of these elements to a running sum, and then returns sum over how many. And if I want to use this, I can just say answer equals average x. Any surprises here? So you touch on structures in 121, and we touched on them a little bit in 224. That's the basic idea. Yeah.
Part I'm still wrapping my head around is why you initialize a struct inside defining the struct. I'm just trying to figure that out.
Why you what?
It says struct my data, struct my data. I'm just trying to figure out why. I'm sure the answer is easy.
This is down here.
See, Brian, I told you.
This is defining what my struct is. This is defining what x is.
That makes 10 million
Okay.
sense. Thank you.
Bad word placement.
ADHD is not my friend.
Do you have to pass in x in there, or do you have to pass in like the and start in and then how many there?
Thank you. That was the punchline, wasn't it?
That'd be my data, wouldn't it?
And then
See, you didn't define.
I was trying not to actually write real code, but I do. So this is x.len and x.nums. Something like that.
This makes my brain hurt way less.
Good.
This is why I ask questions.
Mhm. All right, so structures are what we're going to use to define data structures. Okay, it's going to be the main piece that we use.
Okay, can this be dynamic?
In what way?
So you set up a structure and you want to be able to keep putting data in,
Mhm.
but you don't necessarily know how much data is going to go in there, so you don't know, is it going to be, a struct of 3, is it going to be a struct of 300? When you first, when you first write it, you don't know which one it's going to be.
Right.
So can you make it dynamic where?
Absolutely. So, and in fact, the way I've written this will not work. So this might have been a better, call it nums. Okay, this would be the way we would first do a structure. We'd say here's an array of 100 integers, here's a length, right? And this structure could hold up to 100 integers. But we can make this variable, okay? And in that case, we would do something like integer star nums. But we're going to have to do something more, which I didn't do, so this will segfault the way it's written. So let me leave it like this for now. Right, so that's good for up to 100 things. And we'll basically get into memory allocation. And that's how we do these things dynamically. So thanks for pointing that out. All right. Something else I wanted to say about this. So we can say x.nums, x.length, and so on and so forth. There's a complication with this. So when we first talked about passing things around in C, calling subroutines, passing arguments, do you remember the buzzwords pass by value? I harped on this a fair amount in 224. When you call x equals 5, my subroutine x when I pass this value, this argument to a subroutine, x is not being passed. What's being passed is the value of x. Okay, this is exactly the same thing as if I had said my sub 5. Which means that inside my sub, if I do this, it has no effect on the value of x over here. Because I didn't pass x, I passed 5. So when my sub is executing, it sets its copy of x to 5, and here it sets its copy of x to 0. Nothing to do with this x up here, right? Which means if I have a subroutine that's supposed to change the value of a variable, I have to do some extra work. I have to pass the address of x, tell it that this is a pointer to x, and then do something like the thing pointed to by that address should be set equal to 0. That's why you use those ampersands when you do like a scanf. Because scanf is a function that's supposed to change the value of those arguments. You've got to pass the address. So you do an ampersand variable. So we can do this with structs as well. And we'll usually do this with structs. Typically, we'll do something like, say, call some subroutine and we'll pass it the address of, in this case, x. So we don't actually pass the structure, we pass the location where the structure is in memory. And to access the pieces of our structure, now we need to do something like the thing pointed to by x dot nums, or the thing pointed to by x dot length. Yeah. All right, let's take a 5-minute break. We'll talk more about addresses.